Greetings and welcome back. Today we'll be looking at our second functional group in terms of nomenclature. We already covered the nomenclature of alcohols, and next we'll be looking at, today, the nomenclature of alkenes. So let's start out with differentiating alkanes from alkenes. This is just a 4-carbon alkane, and it is called butane. This is a 4-carbon alkene, and so we turn the word butane into the word butene. So the way that we name alkanes is we start with the word alkane, and we turn alk into but or whatever. Ane stays the same, but when we turn an alkane into an alkene, we turn the alk into, in this case, but, right? That's based on the number of carbons, and ane becomes ene. So this is butene. The way that we would number this, if this is the only functional group, is that we would number it so that the functional group is closest to number 1, which it is. And so with the alkene, an alkene spans 2 carbons, but we only number where it starts. And so if you have the butene starting at number 1, the assumption, which must be true, is that that alkene is going from carbons number 1 to carbon number 2. So this would be 1-butene, or you could also do but-2-ene. Once again, what we have done is replaced that ane at the end of the alkane with ene for alkene. And so if you only have one alkene, that's how you do it. That's how we do it every time. But what if you have multiple alkenes? So for instance, this molecule right here, it's a hexane, but it has 2 alkenes. Well, if we had 2 methyl groups, we would just say dimethyl. So if we have 2 alkenes, we say diene. So in this case, we would replace ane with, when we put the A, we actually leave the A in there, a diene. And so hexane would become hexadiene because we have 2 alkenes. Once again, we should number, if you look at this, the numbering rules are the same. We find the main chain, which in this case is no problem because it's just laid out for us, but we number from the side closest to the first functional group. 1, 2, 3, 4, 5, 6. In this case, we have 2 alkenes. One of them starts at carbon number 1, one of them starts at carbon number 3, so this would be 1,3-hexadiene, or you could do hexa-1,3-diene. All right, so big picture, that's how you name these. But there's a twist. Dienes, much like chiral carbons, can take on multiple stereoisomers. So here's a diene, and here's another diene. The one on the left, if we number it, we should start on the left because that's the closest place where we can run into our alkene first. If you do it from the right side, it would be at carbon number 3. The left side, it would be carbon number 2. So this guy would be called 2-pentene, or pent-2-ene. The one on the right, if we number, we should number the same way, 3, 4, 5. And the one on the right is also 2-pentene. But double bonds cannot rotate. You may recall that double bonds are composed of both sigma bonds, which can't rotate, and pi bonds, which cannot. Therefore, these are stereoisomers. They, therefore, need to be differentiated using some type of naming system. So, just like we do with R and S, we have a way to differentiate the 2 different possible versions of any alkene. All right, and the way that we do this is actually almost exactly the same way that we do it for R and S. But what we do is we take the 2 sides of a double bond. So double bond is a carbon, double bond, carbon. And for each of those guys, we look at the 2 substituents on one carbon and rank them 1 and 2. Well, and we do this the same way that we did for RNS. It's called the Kahn-Ingold-Prelog rules, but it's just by atomic number. So carbon is higher atomic number than hydrogen, therefore this would be number 1, and that would be number 2. On the right side of this guy, we have 2 substituents coming off, and we would rank these 1 and 2 as well. The carbon would be number 1, and the hydrogen would be number 2. And then what we do is kind of draw an imaginary line straight down that double bond, and we look at whether or not the 1s are together or apart. So here you have a 1 and a 2, and here you have a 1 and a 2. So notice that the 1s and the 1s, so here's a 1 and here's a 1, are not together. And when they're not together, they're apart. And the German word for apart is entgegen, and so, which is spelled like this, entgegen. You get to learn a little bit of German, but we just use E. So we would indicate that this is an E-pentene. We would put this as 2E-pentene. All right, so let's do the same thing on the right. So this molecule over here has 2 carbons, and for each of those carbons, we're going to rank their substituents as 1 and 2. A carbon would be 1, and a hydrogen would be 2. Likewise, on the rightmost carbon there, we have a 1 and a 2. And notice that in this case, the 1s are together. They're not on the same carbon, but they're on the same side of the double bond. And together, in German, is zusammen, kind of like same. And so we use the letter Z to indicate that your 1s are together. So this would be 2Z pentene. And so that's how we can differentiate them. R and S are used when we have to rank 4 things around a chiral carbon. E and Z are used to rank when we have 2 things on each side of an alkene. And we look for whether or not the 1s are together, which is zusammen or Z, or if they're apart, which is E, or for entgegen. All right, so do an example of this, and then we will jump into whatever is next. So the last thing we need to do is to compare the priority when it comes to functional groups. There is a whole list of priority for functional groups, and this comes to, well, what if we have a situation where there is a double bond, and that gives us an alkene, and we have an alcohol. All right, these are 2 different functional groups. So where should we number from, right or left? And so this is why we need to have a priority. So there's a setup priority that you have to follow in terms of functional groups, and this goes for numbering and also for naming sometimes. So the only ones we've done so far are alcohol and alkene, and alcohol comes above alkene, and then anything else just comes down here. And anything else includes, at this point, alkane, and we've also mentioned alkyl halides. They're all just halo. So alcohol comes first, alkene comes second, anything else comes third. All right, so with this molecule in mind, let's go ahead and name it. We can find the main chain. The main chain would include all of these carbons right here. Remember, the main chain must include the highest priority functional group, but if it can also include the second highest priority functional group, you should do that. And also remember that OH does not have to be at the end, it just has to be attached to a carbon within the main chain. And then we want to number, that's step number 2. We want to number closest to the highest priority functional group. And so because alcohol is a higher priority than the alkene, we should number in this case from the right. So this would be 1, 2, 3, 4, 5, 6. All right, and then we should name the substituents. The only substituent we have is right here. That's just a 2-methyl group. But in this case, kind of the tricky part that's coming in, or at least the new part for us right now, is going to be that we need to name that main chain that has both an alcohol and an alkene. So let's go back to examining just the word alkane. The alk gets replaced based on your number of carbons. So for instance, this guy has 6 carbons, so it would be hex. Remember, with alcohols, we just take that last E and we can replace it with all for alcohols. But with our alkene, we replace ane with ene, so there's actually no conflict here. We would have a molecule that's a hex, in this case, hex-ene-all. And we replace that E right there, so that would go away. This would just be hexene-all. So the main chain on this guy is called hexene-all. But we need to say where our ene and our all are. Because there's two things that are involved in that main name, we need to number inside the name instead of just in front. If you put the numbers in front, you wouldn't know which number was talking about the alkene and which number was talking about the alcohol. So this, the main chain, would be hex 4-ene, because the alkene, the lowest number in it, is number 4. Again, the assumption on that is that the alkene just goes from 4 to 5, which it does. And it would be 2-all, because the alcohol is at carbon number 2. And we have a substituent, so this would be a 2-methyl hex 4-ene-2-all. But there's stereochemistry. The carbon at location number 2 is neither R nor S, because you'll notice it has 2 methyl groups coming off. So in this case, you get to dodge R and S. However, you do need to be able to do that. But what we have to do, which is prudent for today because we just learned how to do this, is for that alkene, we need to be able to say whether it's E or Z. Sometimes it's neither. So for instance, if you had this alkene right here, you can't compare an H versus an H. They're exactly the same. And so we wouldn't have to worry about E and Z. But if each of those carbons has 2 different substituents, which this one certainly does, we have to rank those as 1 and 2 and 1 and 2 and then sort that out. So I'm going to change colors on this. I'll do it in pink. So on the leftmost carbon, we have an H and a C. The C would be 1, the H would be 2. All right, on the rightmost carbon, we have a C and an H. Again, the C would be number 1, the H would be number 2. And therefore, notice that our 1s are not on the same side of the double bond together. We have a 1 over here and a 1 over here. So those are apart, and apart is E. So we would put that E either way out front, or, as is more frequently done, you would just stick it right in here to where we're talking about the ene. So this could be known as 2-methyl hex 4-ene 2-all, or you could just put the E in front, just like we do with R and S, and say E 2-methyl hex 4-ene 2-all. All right, hopefully you realize this is going to take some practice. So please do, and bring any questions to class, and we will just practice together in class. Thank you very much, and I'll see you soon.